Today we're going to discuss transformations of quadratic functions. Transformation form is also known as vertex form. Transformation form has several benefits. The first one is that you can easily identify the vertex, which is an ordered pair located at HK. The vertex is the highest or lowest point on a parabola. Another benefit is that you can easily find the axis of symmetry. The equation is x equals h. The axis of symmetry is the vertical line that divides the parabola in half. Also, you can find the transformations or changes that make that graph different from the parent. Pause the video so you can copy down these 7 examples. And looking at number 1, we notice that the A value is negative. Because the A value is negative, it is going to cause the parabola to reflect across the x-axis. So this parabola is going to look like a frown instead of a smile. For number 2, h is negative 5. H will always be found inside of parentheses, and it is the opposite. When you look at the equation for transformation form, notice that h has a minus sign in front. That minus sign can be read as the opposite. So h is the opposite of positive 5, it is negative 5. Whenever h is negative, it moves the parabola left. So this parabola will go left 5 units. For number 3, the 5 moves in front of the x squared, which means that that is your A value. When the absolute value of A is greater than 1, it vertically stretches. So when the absolute value is greater than 1, it vertically stretches, which means it's going to appear narrower than the parent. For question D, number 4, d of x, that negative 5 is the k value, is not inside of the parentheses, so that is k. K is negative 5. K will move your parabola up or down. And because this one is negative, it's going to move it down. For number 5, we're back inside of our parentheses again, which means that that is h. And again, we read that as the opposite. So the opposite of minus 5 is positive 5. So in number 5, h is positive. So this parabola will move right 5 units. For number 6, that positive 5 is not in your parentheses, which means that is your k value. When k is positive, the parabola will move up 5. And number 7, the A value is 1/5. When the absolute value of A is in between 0 and 1, it is vertically compressed, or it's going to appear wider than the parent. So now let's graph. Take a second to pause the video so you can write down your equation and set up your graph. Okay, in the previous lesson, you learned how to graph a parabola. I have already written down the parent table for y equals x squared. Y equals x squared is the parent quadratic function. And in this function, you're taking your input, which is x, and you are squaring it. So I chose 5 x values, and then I took those 5 values and I squared it. Keep in mind that whenever you square a negative, it becomes positive. The domain and range for every parent quadratic will be the same. The domain is negative infinity to positive infinity, and your range is from 0 to infinity. So now let's look at this function that we have at the top. And let's find our a, h, and k and describe how this graph will be different from the parent. In this function, a is 3, which means that it is going to be vertically stretched. Remember, when a is greater than 1, when the absolute value is greater than 1, it vertically stretches or it appears narrower. The h value is -1. That can be found inside of the parentheses, and it is the opposite. So because it's negative, it is going to move left 1 unit. The k value is -4. So it's going to move down 4 units. When we apply the transformations, we will always add the h value to x, and we will take our y values, multiply them by a, and add k. So in this function, because h is -1, I'm going to add -1 all the way down to all 5 of these values. Because my a value is 3, I'm going to multiply the y values by 3 and add a -4. Feel free to pause the video so that you can calculate your new order pairs for the transformation function. And I'm going to put those order pairs right here in the center. So this is where I am going to put the order pairs for this function. So find your points and graph it. Pause the video. Hopefully this is what your graph looks like. After I added -1, these were my new 5 y values. And when I multiplied the parent y values by 3 and added -4, these were my new y values for my transformation. So then I just plotted each one of these ordered pairs. -3, 8 was a point, -2, -1 was a point, -1, -4 was a point, 0, -1, and then +1, +8. And when we look at the purple parabola, we can see the 3 transformations that we described in the beginning. It is definitely narrower or vertically stretched. It definitely moved left 1, and it also dropped down 4. The domain for our new function is still all real numbers because we can square any number. So we do not need to restrict our domain. So our domain goes from -infinity to positive infinity. However, notice that my new range, the range is no longer 0 to infinity, because on the purple parabola, the lowest y value is at -4. So my range begins at -4 and it ends at positive infinity. The vertex is the lowest point on the parabola. So the very lowest point on the purple parabola is actually at -1, -4, which, if you remember, is our H and K. The vertex will always occur at H and K. The axis of symmetry is the vertical line that would divide this parabola into two halves. And that vertical line would occur at x equals h, which, again, is -1. So, you've graphed your first parabola. Let's do one more. Okay, so this is example 2. Go ahead and set up your graph in your table and plot your parent. Okay, so now we have plotted and graphed our parent function. The same parent function that we used in the last example. Every quadratic equation will have the same parent function. So let's identify our transformations. So for this example, a is actually -2. And because it is -2, that is going to cause this parabola to reflect across the x-axis. So remember, this one is going to look like a frown instead of a smile. Also, because the absolute value of -2 is +2, it is going to vertically stretch. The h value is inside and opposite. So it's a +3. So it's going to move right 3. And the k value is 6. So this parabola will move up 6. So now I'm going to apply the transformations just like I did in the last example. We always add h to x. So in this example, h is 3. So you're going to add 3 to your domain for this example. Your y values will be multiplied by -2. And then we're going to add 6. Feel free to pause the tape at this time so that you can apply your transformation and also graph your second parabola. Okay, so now let's look at our graph. And again, you can see that the 4 transformations that we predicted, we can see all of those changes in our second parabola. The purple parabola is reflected down across the x-axis. If you look closely, it is narrower or vertically stretched. The vertex did indeed move to the right 3 and up 6. And these are the 5 ordered pairs. The first one was at 1, -2. And then the second one was at 2, +4. The third one is at +3, +6. And then it went to +4, +4. And the last one here is at +5, -2. The domain of every quadratic function will be the same. All real numbers or -infinity to infinity. Let's look at the range. This is different from the parent because it is reflected down. So the range is y is less than and equal to 6. To write that in interval notation, whenever it is less than, we begin with -infinity. Because -infinity is the lowest number or the smallest number, and it's on the left side of the number line. So we begin our interval with -infinity, and it ends at +6. The vertex in this example is the highest point. The highest point is still at h and k, which in this example is at +3 and +6. So this is our vertex. Right here. It's the highest point. And the axis of symmetry. If we draw a vertical line at x equals positive 3, that is the center of this parabola. It is where that parabola will be split into two equal halves.